The floor is yours.
Thank you very much for the kind introduction, and it's a pleasure for me to present here today in behalf of all my co-authors. Drug resistance and HIV co-infections are challenges for the global control of tuberculosis, TB, for patients with multi-drug resistance, MDR-TB, and extensively drug-resistant XDR-TB due to limited access for rapid drug resistance testing and to appropriate TB treatment in many high TB burden countries. We aim to assess the impact of discordant anti-TB drug susceptibility testing performed locally versus the reference laboratories and to assess mortality in HIV-positive and HIV-negative patients in lower and middle-income countries. The objectives for our studies were to compare drug susceptibility testing, DST, performed at ART programs or TB clinics versus phenotypic DST performed at the Swiss National Center for Mycobacteria. Then we compared mortality during TB treatment by concordance or discordance of DST results, by the degree of drug resistance, and by TB treatment adequacy. We collected clinical data and Mycobacterium tuberculosis isolates from adult TB patients stratified by HIV and drug-resistant status in 7 high TB burden countries. The map below shows you the percentage of newly diagnosed rifampicin and MDR cases, and the stars represent the 7 selected countries, namely Peru, Ivory Coast, Nigeria, the Congo, Kenya, South Africa, and Thailand. The HIV-positive patients were recruited from the International Epidemiology Database to evaluate AIDS, or IDEA, and the HIV-negative patients from TB clinics in the same catchment area. All the clinical data were collected electronically using REDCap. All sites screened their patients' isolates using available methods such as liquid or solid culture, GeneXpert, or line probe assays, or a combination of these tests. And confirmatory testing was, as already mentioned, performed at the Swiss reference laboratory using liquid culture MICHIC with the following drugs listed below and with their critical drug concentrations. We collected a total of 871 isolates. However, we had to exclude 237 isolates, mainly due to nut growth or contamination for the first analysis or for the first outcome, the comparison of the DST results, and the further 61 patients had to be excluded for the mortality analysis, mainly because the patient was still ongoing treatment or the treatment outcome was unknown at the time of data closure. The median age of our patients was 33 years old, and a total the female and the percentage of females was 38. 42% of our patients were HIV positive, with a median CD4 count at start of TB treatment of 192 cells per microliter. Comparing HIV-negative patients to HIV-positive patients, HIV-positive patients were more likely to be females, were more likely to have both extrapulmonary and pulmonary disease, and were more likely to have a negative smear microscopy result. This table shows you that almost 81% of the results from the reference laboratory compared to the local laboratories were concordant, and the remaining 19% were discordant. Among the discordant DST results, 4% were potentially leading to non-treatment, 11% were potentially leading to an over-treatment, and the remaining 5% were other discordants. On the right-hand side, you can see some examples. if we include the treatment which the patients received, we found among the concordant results that almost 97% received an adequate treatment compared to 78% among the discordant DST results. Now we move on to the analysis on mortality. Mainly briefly, the figure always shows you the univariate result, and the table below shows you the multivariate results adjusted for sex, age, sputum microscopy, and HIV stages. The figure shows you that mortality was around 8% if the DST result was concordant, and was ranged up to 40% if the DST result was discordant, potentially leading to an undertreatment. Similar was seen in the adjusted model, which showed that the odds of death was 9.5 if the DST result was discordant, potentially leading to an undertreatment. Not surprisingly is that patients with a pre-XDR or an XDR TB had the highest mortality compared to patients with a pan-susceptible TB. This was seen in the unadjusted as well as in the adjusted model. And the results for treatment adequacy, we separated the analysis by patients with a pan-susceptible TB and also treatment adequacy and inadequacy. Inadequacy includes patients which received an under or an over treatment. And the figure shows that patients with a pan-susceptible TB adequately treated had a mortality of around 6%, while patients with any type of resistance inadequately treated had a mortality of 53%. Comparing patients with a pan-susceptible TB adequately treated, the adjusted odds of death was 4.2 if patient had any kind of resistance and received an adequate treatment, and had an odds of death of 21.5 if they had any type of resistance and received an inadequate treatment. None of these results, which was highly significant also, as you can see on the confidence intervals. HIV status, sputum microscopy, and sex was in none of the adjusted models associated with mortality. Of course, our study also has limitations. First of all, due to our sampling strategy, we are not able to estimate the prevalence or the incidence of drug resistance in HIV positive or HIV negative patients. Although we exceeded our planned sample size, it was quietly reduced due to bacterial contamination or missing information. Also, we have to acknowledge that some of our discordance might be explained due to heteroresistance, mixed infections, or minority-resistant populations. And of course, also, at the reference laboratory in Switzerland, we only tested common first and second line drugs and definitely have missed resistance to other drugs. In conclusion, our study showed that discordant DST results were associated with inadequate treatment and contributed to excess mortality associated with drug resistance. Our study supports the notion that access to detailed DST testing for first and second line drugs at treatment initiation is needed to improve treatment outcomes in patients with drug resistance. Understanding factors contributing to discordant DST results is necessary to improve diagnostics and treatment outcomes. I would briefly say that we just submitted the paper to the Lancet Infectious Disease, and the pre-printed version is available on the link below. And finally, I would like to thank the IDEA, Matthias Ecker and his team in Bern, Sebastian Gagnon and his team in Basel, and Eric Böttger and his team in Zurich, and of course our founders, the NIH and the Swiss National Foundation. Thank you for your attention. Are there any questions?